A total of 20 boys and girls attended a performance in the school hall. Three-quarter of the boys and half of the girls left the hall after the performance ended, and there were 7 children remaining in the hall. So how many girls were there at first? All right. So as we can see here, there is a transfer happening in this question, and the transfer is that there are some boys and some girls who left the hall. Okay, so this is an external transfer. Leaving the hall is external transfer. All right. So for these two transfers involving the boys and girls, as we can see, they involve fractions. Okay, so half itself is, yeah, we can write it as a fraction, 1/2. So when the change involves fractions, we call this proportion transfer. All right. So the concept name is called proportion transfer because it involves a fraction. Or if it involves percentage change, those are also proportion transfer. All right. Now, the beginning information, they gave us a total of 20 children. And in the end, they gave us a total of 7 children. Okay, so how do we record down the data? We shall record it as a before change after. So for this one, we wouldn't use model because I wouldn't know what's the comparison between boys and girls at the beginning. They didn't tell us anything like how many more boys than girls or twice as many boys and girls. They didn't give us such information. Hence, we use before change after method. All right. And then from there, we will see how do we continue to solve the question. And also this proportion transfer, we can rewrite them as ratios, just like what we did for concept 1. Okay, so let's work on that. So total boys and girls at the beginning, I can just put B plus G equals to 20 boys plus girls. So this is your before information. Now, and I'm going to record down the change, which is to draw an arrow. And the change is that 3/4 of the boys left the hall. So there's a decrease in the number of boys. Now, and from this fraction, I'm going to translate it to a mini BCA ratio below. All right, so BCA meaning before change after. So out of 3/4 leave means that out of 4 units, the boys, 3 units of boys leave the hall. Okay, so my before will be 4 units. The change is -3. The after that will be 1 because 4 minus 3 left with 1 unit. All right, so just imagine it's basically understanding what the significance of numerator and denominator is about. If you understand that the 4 refers to the boys at first, you can actually pen it down in your ratio. You understand that the -3, right? -3 is those who left the hall, that will be your change. After that, you just need to do the subtraction. Okay, and we're going to do the same for the girls. So draw another arrow for the girls. Try not to squeeze it in here. So half of the girls leave the hall. Okay, so girls minus half. Again, this fraction, I can translate it to a mini BCA ratio at the bottom here. All right, so we're dealing everything with ratio, although technically this is not a ratio question. We don't see any ratios here. However, it is possible to just change all your fractions into ratio form. All right, because there's a possibility that we could identify certain common bases from there. All right, so 2 units of girls, that will be your before. 1 unit of girl leave the hall, and after that, you're left with 1. And in the end, this is your after data. We're going to record that down. So you see, this is your before. This is the big change. But of course, within the big change, you have mini BCA ratios, and you have the big after. So the after here is that 7 children remain. So B plus G equals to 7. All right. So first step of recording down your data, done. You have completed that. Now, next thing is to identify your common base because we see 2 sets of ratios here. So you need to check, is there any common base between the 2 ratios? All right. So let's figure out one by one first. Let's do the before first. Now, will the boys and girls before be the same? So if you look at the before information here, nothing here tells us that boys and girls is the same at first. So no, that is not my common base. Okay, so we go on to work on the change. -3 and -1, should I make them the same? No, we shouldn't, because the question did not tell us that equal number of boys and girls leave the hall. All right, then we go on to the after. Should the after here and the after here be the same? Again, nothing here tells us that in the end, same boys and girls children remain, right? Equal number of boys and girls remain in the hall. They did not tell us that. Hence, we cannot say that after is the common base. Okay, so notice that between these two ratios, after what I've just went through, there is no common base between the two ratios. So if there is no common base to unite them as a family together, that means you got to treat them separately as two different families. You got to call it units and parts. You got to use your units and parts method, whereby you assign your UU, PP for each set of people. Okay, two separate families now. Whatever one unit value that applies to the boys ratio should not be the same as the one unit value for the girls ratio. Let's say here one unit is 10 boys. Okay, it does not necessarily mean that one part will be 10 girls as well. One part could be something else, could be like 11 girls, 12 girls, anything else. Okay, so that's the reason why we assign UUPP, because there is no common base to unite these two ratios together. All right. Next thing is we are going to use the usable values to see how we can solve the question. Usable values meaning to say that what the question has provided, like what values, 20 and the 7, right? Okay, which is this and this. So we need to identify how many units or how many parts do each of these values represent. Okay, so let's work on that. So let's look at this first. This is boys at first or boys before. So look at your ratio. Boys before, we know is 4 units. So we're going to record that down here. Check for the girls as well. Girls, this is the before section, right? So look at look at the girls before, which is 2 parts. Okay, so 2p. Do the same for this side. This is your boys in the after section. So check out the boys after, okay, BCA, remember. So boys after is your 1 unit. So record that down. For girls, after is 1 part. And there you go. Notice that whatever you have here, you have 2 equations which has a mix of units and parts in each equation. All right, so never add these two together because they're 2 separate things. So we're going to rewrite the 2 equations. 4u plus 2p equals to 20 from here. And this one will be 1u plus 1p equals to 7. Okay, now moving forward, I need to solve using these 2 equations. Okay, now however, the difficult part here is this. I have units that is unknown, I have parts that is unknown. All right, so how am I going to solve using these 2? Now, when you have 2 equations like that with 2 different unknowns, your aim is to get rid of one of the unknowns. That means you either get rid of the units or you try to get rid of the parts. Okay, now for this is really up to you because both equations shows an addition. It is quite flexible for you to decide if you want to make units, you want to get rid of units or you want to get rid of parts. Okay, so if I want to get rid of units, I must make units the same value for you. If I want to get rid of parts, I will make parts the same, 2p, 2p. Okay, I hope you all are all clear on this. All right, so in this case, I would choose to make my units the same. That's why I times 4 to this entire equation. All right, but it's really up to you. You want to choose to make parts the same, it's fine. Now, however, if it's like 1 plus, 1 minus, better always make the first one the same. All right, because you'll be dealing with like negative numbers. So we try to avoid that. So no matter what, if it's like plus and minus, make the first one the same. However, now we have more flexibility because both are additions, both are classes. All right, so anyway, I'll just go on to make units the same. And we're going to just draw a line to differentiate my old versus new equations. So rewrite the first equation, that one, no changes, just transfer it down. Second equation, everything times 4, it turns into 4u, 4p, and 28. Okay, so you see, finally I've made units the same. Now notice that since I've made units the same, I can go on to safely eliminate the units. Eliminate means to remove, to get rid of the units. Okay, so to get rid of the 4u, you simply find the difference between these 2 equations. Why? Because finding difference 4u minus 4u, that's how you get rid of the units, right? Becomes 0 units. Okay, so take the difference between the two equations. So difference between these two parts will then be 2p, right? Two parts. For you, the difference no more already, no more units. Okay, you can ignore the units already. And of course, take your difference between the whole number, 28 minus 20, that will be 8. There you go. Can you see I have established that two parts is a value of 8. Now, once you have this, okay, you can go on to find 1p. Now, but in this case, if you read the question, they ask you how many girls at first. Okay, so normally the practice is we go on to find 1p. But because now if I straight away I notice, okay, they want girls at first. So girls at first, actually, if you notice, it will be referring to this one. Okay, girls at first is this one. I've just drawn an arrow. Girls at first, that's your before. Girls before. Or you can look here also. Girls before is 2 parts, which I've already got actually straight away. 2 parts is 8 girls. So that will be your answer. Okay, 8 girls.